Good morning, everyone. Welcome to Software Engineering. I'm Zhang Shuang from Software College, Northeastern University. In this lecture, we are going to learn programming practice. Well, surely different computer languages has different grammar, different functions, different class library, different function library, and so on. Well, there are still some common good programming practice. Okay, so next, let's take some examples to discuss some good programming practice. First, the use of consistent and meaningful variable names. Well, meaningful means to future maintenance programmer. That means when the programmer reads the code, he will understand what variable stands for. And consistent is to aid maintenance programmer. That means this variable, with the same meaning, will have the same name throughout the whole target software system. For example, a module contains variables: frequent average, frequency maximum, minimum frequency, frequency total, and so on. We find that frequency is defined in different ways, such as FREQ, frequency, FR, FRQNCY, all refers to the same thing, actually, frequency. We find that MIN stands for minimum, but some will give out the full spelling, such as maximum or average. Surely, such kind of variable names are very easy to understand. So, variables such as frequency average, frequency maximum, frequency minimum, or frequency total will be good names. You can also define in this way: average frequency, maximum frequency, minimum frequency, and total frequency. Actually, all the four names must come from the same site. So if the variable names are following this style, and you should make sure that all the other variables also follow this style. Developers should always remember that such kind of self-documenting code is existingly rare. That means it is very difficult to get some self-documenting code. Well, actually, the rules to decide whether the code is self-documenting or not should be this. Can the module be understood easily and unambiguously by SQL team and maintenance programmers and all others who have to read the code? So that means programmers, developers must make sure that their code can be understood easily and unambiguously by all the others who are supposed to read your code later. Here we got another example. Let's read these variable names: X, coordinate or position of robot arm. Well, it is a quite long variable name, but you cannot ignore that it is a very meaningful variable name. Almost everyone can understand what this variable refers to. Well, someone will prefer to abbreviate this variable like X. What do you think of this variable? Is it easy to understand? Well, if the whole module deals with the movement of the robot arm, it will be okay, but if it is not the case, what this variable refer to? Is it refer to the coordinate of the position of robot arm, or leg, or head? So it will be really very hard for the maintenance programmer to understand it. So besides some good variable names, programmers should never forget comments. First kind of comments is prolog comments. Prolog comments is mandatory at the top of every single module. And prolog comment should include module name and brief description of what the module does, programmer's name, date this module was coded, and date this module was approved and by whom, module parameters, and variable names in alphabetical order and their uses, and fields accessed by this module, fields updated by this module, module input and output, error handling capabilities, name of file or test data for regression testing, and list of modifications made when approved by whom, and known faults, if any. So you'll find that there's really quite a lot of information inside prolog comments. And this enables anyone who is supposed to read this model to understand the model from the very beginning. And another kind of comments is inline comments. That means the comments inside the module. Comments are essential when our code is written in a non-obvious way. Comments can assist maintenance programmers. Okay. So that means these inline comments are supposed to help anyone, okay, to understand the code, especially wherever the code is written in a non-obvious way. Programmers should also try other ways to increase readability, okay, such as use indentation and use blank lines and some white space. So that means to make the code well formatted. Next, let's discuss about the nested if statements. For example, we got a map, and the map consists of two squares, square 1 and square 2. Okay. So you are supposed to write code to determine whether a point on the Earth's surface lies in the map square 1 or map square 2, or is not on the map. So here you'll find that this area is map square 1 and this area is map square 2. And you get some longitude and latitude to determine the location. Here we got solution 1 based on 1. From the first glance, we find that the code is really badly formatted. It's just a mess, so hard to read. I don't think you would like to read it, right? Okay. Actually, every time I look at this code, I got a headache. Solution 2. The following code is quite well formatted, but we find it's badly constructed. Let's read it together. If latitude is greater than 30 and longitude is greater than 120, if latitude is less than or equal to 60 and latitude is less than or equal to 150, what do you think? Do you understand it? We find that the logic is just a mess. Although it is well formatted, it's really very hard to understand, right? Okay, so it's still not a good example. Solution 3. We find that this code is really well formatted. So let's read it together. If longitude is greater than 120 and the longitude is less than or equal to 150, this is quite clear, right? There is a condition for longitude. And latitude is greater than 30 and the latitude is less than or equal to 60. And then map square number equal to 1. It's really very clear, right? Okay. else if latitude fall in this area, and if latitude fall in this area, and then the location is within the area of map square 2. Else, print not on the map. Okay, so we find that solution 3 is acceptable nested. So we find that the combination of if and if statements is usually difficult to read. That means we should simplify the if condition. Okay, let's say if condition 1 and if condition 2 is frequently equivalent to the single condition, if condition 1 and condition 2. Okay, so the rule of thumb is if statements nested to a depth of greater than 3 should be avoided as per programming practice. So that means never try to make if statements nested too deep. Next, let's discuss about programming standards. Programming standards can be both a blessing and a curse. Actually, no standard can ever be universally applicable. Models of coincidental coherence arise from rules like every module will consist of between 35 and 50 executable statements. So if the programmers have to follow these rules for every module, and sometimes maybe coincidental coherence will arise. So we'd better do and think in this way. Programmers should consult their managers before constructing a module with fewer than 33 or more than 50 executable statements. So that means actually no standards can be applied everywhere. The so-called standard should be some rules case by case. Here are some examples of good programming standards. For example, first, nesting of if statements should not exist at depth of 3, except with prior approval from team leader. Okay. And the modules should consist of between 35 and 50 statements, except with prior approval from the team leader. And use of goto should be avoided. However, with prior approval from team leader, a forward goto may be used for error handling. Actually, when we talk about some examples of programming standards, we should understand that the aim of standard is just to make maintenance easier. If the standards make development difficult, it must be modified. And the overly restrictive standards are counterproductive. And then the quality of software will suffer. Okay, so much for good programming practice. Okay, thank you.